The slaughtering process begins with the animals entering the abattoir. The abattoir primarily produces pork, so pigs are shown in simulation. In the slaughtering process, pigs are transported by conveyor. Production workers use hooks to attach each pig to the conveyor. Each pig is identified by an ear tag. During the slaughtering process, ear tags are removed. Ear tag information is very important for traceability and meat safety. To preserve it, the proposed solution is to use NFC tags that will be attached to the hooks. The worker in the slaughtering process reads the ear tag before it is taken off, and this information is forwarded to the ERP system via the voice control. ERP software will forward this information to the NFC tag through OPIL platform. The proposed voice control device comes with its own software for voice recognition and voice generation. When the worker reads the ear tag, the software will send text value to the ERP software. When the ERP receives the information, it will send a message that the information has arrived to the software of the voice control device, which will then inform the worker by voice that the ear tag has been successfully saved. We get 2 carcasses from each pig. Carcasses represents the final product in the slaughter process. In addition to ear tag information, weight is also entered on the NFC tag during the slaughter process. Each carcass goes over the scale. The scale is part of the Bezerba Brain 2 system, which weighs it on a separate Bezerba server. ERP software reads weighs from this server and writes information to the NFC tag. Carcasses labeled with that information are transferred into conservation chambers. Devening process starts by removing pork belly, head, and front leg from the carcasses. Initially, we have an NFC reader that will send information to the system in which order the carcasses exited the conservation chambers. This information will then be transmitted through production process up to the final product. Pork belly will be placed on special transport cart. Full pork belly carts will be transported to the conservation chambers. This transport will be done with AGVs. The command that the pork belly carts are full is again set via the voice control device. This command is set by the worker that takes off pork belly. Command is transported to the ERP software. ERP software uses OPIL platform in order to send that command to the AGV. For this operation, the AGV with low profile design is proposed. This type of AGV engages carts underneath and transports them so load remains above on the AGV, also called tunnel AGV, undercart AGV, or AGV transfer cart. Regarding the navigation method, the virtual guide path with laser navigation is proposed, due to reason that such system requires no floor installation, which could be problematic in case of abattoir industry with production facilities with tilled and wet floor. The proposed guide path is very simple and assume only 2 service functions, pick-up and drop-off position. At the pick-up position, AGV take the cart, according to information about process completion, which is transferred from the production workers to ERP. At the predetermined drop-off positions in conservation chambers, the AGV automatically releasing the full cart, moves back to pick-up position and hook the next cart. AGV could be programmed to stop at pick-up position, or an operator can call an AGV to a location using a push-button call box. Towing capacity is up to 1,000 kilograms. AGV is fitted with batteries sized to last minimum the operational time. The battery charging could be arranged during off-operational time. 1 charging station is required. Carcasses without pork belly, head, and front leg is called French cut. French cuts are input in devening room. Production workers first use special saw to take French cut in 4 parts: shoulder, leg, loin, and collar. These items are forwarded by conveyor belt. Next to the conveyor are production workers who take a piece of meat, process it, and return it to the conveyor. Each part of meat could be processed on several different ways. For example, leg with bone of leg without bone. Production worker receives information on what type of processing to apply through the voice control system. At the end of the meat conveyor, there is a table for weighing with the scales. Near the workers who perform the measurement process, there must be blank meat boxes with the NFC. The worker receives information via voice command how many items of some type he should place in the meat box, for example 2 legs. He takes a piece of meat, wraps it in transparent foil, places it on the scales. When the label comes out, glues the label over the foil and places the measured item in the box. When he fills the box, he approaches the box with an NFC device that writes the box information into the NFC tag and then places the box on the Euro pallet next to it. Those NFC tags are very important for traceability. Because we know which French cut is entering deboning room, information from the NFC tag on the hook, we know that first French cut produces first leg, and information from the NFC tag on the hook will be used to generate information to the NFC tag on the meat box. When a worker fills a pallet with meat boxes, he or she tells the AGV device to start moving the pallet to the warehouse. The second type of AGV is forklift AGV, used for transfer of pallets with meat box units from deboning line to the warehouse with the robotic arm, as well as for transport of finally palletized goods from robotic arm to expedition warehouse. Also, the same AGV is used for transport of palletized goods from expedition warehouse to the loading dock for delivery. In all of these transfer operations with forklift AGV, the virtual guide path with laser navigation is proposed. The proposed guide path assumes basically 2 service functions, pick up and drop off, with several different positions. AGV stops could be controlled automatically from ERP, or manually according to information from operator using a push-button call box. Towing capacity is up to 1,000 kilograms. AGV is fitted with batteries sized to last minimum the operational time. The battery charging could be arranged during off-operational time. 1 charging station is required. When the pallet reaches the deployment chamber, the robotic arm takes over the meat box. The robot that prepares meat boxes for the expedition has to be able to pick meat boxes from the incoming pallet and place them on one of the pallets for each region. Here, the robotic arm should read the meat box via the NFC tag and, based on the information, determine which pallet to place that box on. For example, information is that in the box we have 2 legs from animals with year tags RS111 and RS222, and total weight of those legs. ERP software receives information and sends back information to the robot arm to place that box on pallet that is on position 2. 1 pallet can stack 4 meat boxes on 1 horizontal level. A meat box filled with meat can weigh around 30 kilograms maximum. Thus, based on the load and workspace requirement, a robotic arm IRB 4600 from ABB is selected. In terms of precision and repeatability, this robotic arm fulfills the requirement for this operation. It has pose repeatability of 0.06 mm and accuracy of 0.02 mm. It is an arm that can carry the load of up to 40 kilograms and has a reach of 2.55 meters. Since the robotic arm can't reach all 5 Euro pallets, the track motion system IRBT 4004 is selected to expand the robot's workspace horizontally. The speed of the track motion system is 2 ms and the speed of the robotic arm under full load is 1.6 ms. To verify the reachability of the robotic arm in a workspace, a simulation and offline programming with the selected robot and track motion is performed in Robot Studio software. Based on the requirements and selection of the robotic system, a layout and visual components software is prepared. The selected robotic system is compatible with ROS Industrial and therefore simplifies the integration with OPIL. Filled pallets are transported from the robot arm warehouse to the expedition warehouse. The expedition is done by transport plan. The ERP software plans which truck will be used to transfer pallets to the customers. When the truck arrives, the production worker, via the voice control device, gives the command that the truck has arrived. This information goes to the ERP software. ERP filters data and finds which pallets should be loaded. That information is transferred through OPIL to the forklift AGV. AGV receives location of the pallets, and those pallets are transferred to the expedition ramp. When pallet with AGV reaches expedition ramp, production workers pick up pallets and place them in a truck. Once all the pallets are in place, the worker through the voice control device gives the command that the expedition is complete. Gives the command that the